In problem number 5, the temperature in degrees Celsius of the water in a pond is a differentiable function W of time t. And the table above shows the water temperature as recorded every 3 days over a 15-day period. First, we want to use data from the table to find an approximation for W prime of 12 and show the computation that leads to your answer, indicate units of measure. So we want to find, or we want to approximate, the derivative at t equals 12. Well, the easiest way to do this is to use an average rate of change using the 2 points on either side of 12. Since we don't have a function that we can take the derivative of and find the derivative exactly at 12, we can use the slope of the secant line through t equals 9 and t equals 15 and use that to approximate the slope of the tangent at 12. And so we use w of 15 minus w of 9 over 15 minus 9. That comes out to be 21 minus 24 over 6, and that's negative 1/2. Second, for part B, we want to approximate the average temperature in Celsius of the water over the time interval from 0 to 15. And so here, since we want the average value of the temperature function, then that is the integral divided by the interval. So we multiply by 1 over 15, which is the width of the interval, times the integral from 0 to 15 of w of t dt. Now we don't have a function for w of t, so there's no way that we can find the antiderivative of that. So what we're asked to do here is to use a trapezoidal approximation with subintervals of length delta t equals 3 days. So we can only approximate the average value of that function. And the first thing we're going to have to do is make sure we multiply the end result by 1 over 15. Then, since the width of each subinterval is 3 days, for the trapezoidal approximation, h over 2 is going to be 3 over 2. And we'll factor that out. And then remember that we're going to use 1 of the first and last, and then double each of the interior. So we'll have 1 times 20 plus 2 times 31 plus 2 times 28 plus 2 times 24 plus 2 times 22 plus 21. So I can simplify my fractions. I'll get 1/10. 20 plus 62 plus 56 plus 48 plus 44 plus 21, and that'll be 251 over 10, and that is degrees Celsius. And you can see that 25.5 is very consistent with all of those values that were given, and it is an approximation. Now, one could easily just add up those values and divide by 6, and we'd get a great approximation for the average temperature of the month. But we have to do it the calculus way. Now, going back, there is something that I forgot in part A. I did not give the units of measure. And W prime of t is going to give the rate of change of temperature per day. So the units there should be degrees Celsius per day. In part C, a student proposes p, the function p, given by p of t is equal to 20 plus 10 te to the quantity negative t over 3 as a model for the temperature of the water in the pond at time t, where t is measured in days and p of t is measured in degrees Celsius. So we're looking to find p prime of 12 and using appropriate units to explain the meaning of your answer in terms of water temperature. So I'll call up the graphing calculator. We'll go to y equals, enter our function, and so that's 20 plus 10 times x times e to the negative x over 3. And recall that this is a model for the temperature of the water, and what we're looking for is the rate of change of temperature. So I'm going to go to math, nderiv. So that's nderiv y1 x and 12, and we get a value of negative 0.549. And so I'll move the calculator over, and the units there will be degrees Celsius per day. And that is how fast the temperature is dropping on the 12th day.